Okay, so I'm going to be talking this week about forestry sampling. I thought we'd go into resource management here shortly while we tool along here. So I'm going to try to get through this and give you some ideas of some things to try out. Give you an assignment. You can either do it outside or you can do it inside, and we'll see how that all goes. So I'm just trying to give you some options here. It's going to lead up to actually a project that we're going to be doing on the different types of management of resources that there are out there. So I wanted to kind of give a example for you to take a look at. So forestry management, a little bit of background, and I'm not going to read this to you. You can read through it as you need to. But basically, forestry products and wood and everything that's related to trees has been used for at least 1,000 years. Many, many more thousands than that if you count ancient Egyptian cultures and Asian cultures. And trees were a resource that people used quite a bit. It wasn't until the early 1900s or so that people started to realize that there's a way to manage this a little bit better than what we had. Up until that point, we had just kind of gone through forests as completely renewable and something that you didn't really have to worry about. We could go and chop down the forest. There's always more forest someplace else. Don't worry about it. So humans kind of rampaged throughout the world and just chopped down trees and forests wherever they encountered them. And it was about the 1900s that a number of countries kind of figured out that if we're going to continue to do this and we're going to continue to use wood products, we need to have a better management system. Scandinavian countries were the first ones that kind of came up with that, and they made some drastic improvements in the way that we managed forestry resources. And we still use those practices now. So the biggest issue is that the Scandinavians noticed that water drainage, habitat loss, wildlife displacement, all of those things were really, really big factors along with logging. People hadn't really considered that before. They had never, again, that whole ecosystem thing, they never really considered an ecosystem. So we really had to adapt a different policy. So currently there's two main policies to logging or forestry that's done throughout the world. So there's two main approaches here. The first one is clear cutting, and it's a pretty common practice. They try to do it in smaller pieces now. Clear cutting used to be done for like entire states. If you look at Minnesota and you travel around anywhere in northern Minnesota, you'll recognize that most of the trees around here are about the same age as far as the oldest trees. There's not really a tree in Minnesota in the interior of Minnesota that's over really 120 years old. That's because in the 1800s, late 1800s, lumberjacks descended upon this area and just basically leveled off every tree that existed. And they did it in massive ways, and that clear cutting was done in huge destructive ways. Now when we do it on smaller plots of land. We usually do it on 40 acres or less. It's the pros to this whole thing is that it's quick and it's efficient. It's relatively cheap. You can just run your machinery and get through it and buzz through it. And it's a lot less resources than other techniques, which we'll find out about here in a second. The cons are that it removes a lot of habitat. As you can see, I went out and drove around my four-wheeler last weekend looking for examples of these different forestry techniques. So that's why you see these pictures here. So this is actually about a mile from my cabin or so. And they just recently did this, like over the winter time, they logged off this little spot here, and this is kind of just a different angle of the same spot. The cons of it are habitat removal. Obviously, you can see they just level down everything, and they cut off every tree, and they cut off everything, and they just leave stumps, and there's not much left. The water table and the water drainage is also a major issue. So these hillsides that used to have roots and all kinds of trees and things soaking up all of the water that would come down now don't have that. So erosion becomes an issue, etc. The other part of this is that it takes a long time for this forest to recover. So 50 to 100 years or so. And if you want to kind of see what that progression looks like, this is a spot here that was clear cut about 3 years ago. And you can see some of the evergreens kind of popping back up here and a few little things. And it's a lot of shrubby, brushy types of stuff kind of coming up. And then this is about 8 to 10 years later. So this was a spot that got cleared off about 8 to 10 years ago. And you can see kind of these sapling, kind of hardwood trees, a lot of birch, a lot of quick, wiry growing trees kind of establish themselves here about 8 to 10 years later. And then after that, the pines finally catch up And this is about 20 years after clear cutting, where you can see the birch trees have grown up, but the pine trees are now starting to grow and shade out things underneath them so you don't get all that scrubby stuff that's underneath there. And then finally, mature pines take over. This takes about maybe 50 to 100 years after they clear cut an area. So that's what the forest is going to look like in about 50 to 100 years now. So it's pretty damaging. It's pretty time consuming as far as to replace that environment. So there's another alternative, and that alternative is called selective harvest. And logging companies can use smaller equipment. They even in Minnesota, there's a lot of horse-drawn lumberjack companies. They use horses. They literally drag teams of horses through the woods because machinery can't do this very well. What they do is, if you can see in this picture over here, they'll choose out specific trees. You can see where they've cut down trees in the middle of this forest, and they lay them down, and then they have to drag them out. If you use machinery, it rips up the soil and it creates ruts, and it's really problematic. So they actually use horses for this even still today. So it's time consuming. It's one of the cons. I'll start with the cons. It's really time consuming. It's really, really expensive to do this compared to clear cutting and just buzz cutting everything. You need really, really large forests and mature forests in order to make this work, because you need the ability to pick and choose specific trees and not ruin the forest. The other con here is that it's really inefficient, and it uses a ton of resources compared to clear cutting. So the resources, you're constantly walking and burning gas and using machinery to get back to places where it's really hard to access a lot of things. So it can be problematic for that. The pros, obviously, it allows the forest to continue to grow in its space, and it allows new, younger trees to start to develop. You can probably see this little sapling starting out here. And the habitat is not disrupted. And the nice thing for the people that actually put the time and effort into this is that the loggers that take this wood, usually they can sell those fine pieces of lumber at luxury prices, and so they can get a lot of money for it. But they have to convince a buying audience, basically, that that's important. So that's selective harvest. All right. So the question is, how do you determine whether or not a forest is ready to be harvested or not? And I'll use the example of a junk drawer in your kitchen. I'm hoping that your family is like my family and you have a junk drawer in your kitchen. Elizabeth, I think you're probably the only one who doesn't. The reality is that this junk drawer exists probably in your house where you've just thrown pencils, rubber bands, scissors, calculators. You can see it in here, and I'm hoping you have something that's relevant in your life that you look at. Yep, I got one of those. Let's assume this junk drawer is filled with things that you want. Like, you just want to take all the pencils and pens and markers and all the writing utensils out of there, and you want to find out how much volume are they actually taking up. Well, if we use the analogy to a forest is a whole bunch of different things. It's rocks, it's soil, it's shrubs, it's grass, it's little animals, it's all kinds of things, but it's also wood, it's also lumber. And so how do you extract out, how do you pull out just the lumber without actually pulling it out, without actually taking it out, without cutting it down and then going, yeah, this was a good enough spot? You kind of have to estimate these things beforehand. So what we're going to try to do here with this technique is that we're going to try to sample, get a visual idea of what would it look like if we chop down all of the trees in the forest and bundle them up, and how much volume would that actually be? And is that going to be worth our time to actually harvest? So that is what this is about. Okay. Now, I've done the process. I went out today and recorded a video of myself demonstrating this process. It's pretty simple. It's a 3-minute video. I'm going to post this so that you have this link so that you can go to it. It's pretty straightforward. You'll see how it works. It's really quite unique, and it seems like it's pretty stupid, but it's actually pretty, it's very, very good at estimating these things. And then you'll want a worksheet. There's a worksheet that goes along with it. It's just data tables. All right. So ultimately, the main idea, without taking too much time here, is that you start at a starting point, and then you break your starting point into fourths, into quadrants. So you have like quadrant 1, 2, 3, and 4. Usually they do it with north, south, east, and west, but it doesn't really matter. It's arbitrary. You start with a starting point, and then you determine the distance to the nearest tree that has a diameter breast height, and like at your chest, of 10 centimeters or more. So 10 centimeters is only 4 inches. So you basically figure out, where's that closest tree that's in that first quadrant? Is it here, or is it over here, or is it far away, or is it really close? You do that in quadrant 1, you do that in quadrant 2, you do that in quadrant 3, and you do that in quadrant 4. You figure out those distances, and you also measure the diameter of the tree. So that's what you're going to do. So you're going to stand in a spot, break it into quadrants, and then figure out the distances and the diameters of the 4 closest trees that's at least 10 centimeters in diameter at chest height. Okay? And I did put on here that diameter breast height, it is a very weird term to me. I don't really get it. I think the old timers, honestly, the old lumberjacks spent way too much time alone in the woods or something. I have no idea. Anyway, you're going to record all this stuff. I'll just kind of fly through this. You guys can read through it when we're done here, or you can watch the video and you don't have to read any of this. But basically, you're going to get a bunch of distances and you're going to get a bunch of values for trees. You're going to repeat this process for a total of 4 data sets. So you're going to find one starting point. You're going to run through it, and then you're going to finish out, okay? So ultimately what you're going to do is you're going to figure out your calculations then. You're going to calculate your average distance in meters to any tree in your plot. So you had 16 trees, you divide by 16. And so you're going to get an average distance. And then you're going to take this, you're going to figure out the density of the trees then by using that average distance. That density is a really kind of a weird thing because people have a hard time understanding that. Let's imagine that you figure out the average distance traveled to a tree. So if you start in a spot and you're standing like right on a tree, and then you walk to that average distance, you should bump into, theoretically, another tree. And then you walk that same distance again, you should bump into another tree. And then you walk that same distance again, you should bump. If you walk in a square, you've got a distance squared. You have an area here that you've traveled. And notice that you haven't bumped into 4 trees. You've actually bumped into 1/4 of this tree, 1/4 of this tree, 1/4, and 1. You've bumped into a total of 1 tree in your walk. That's the theory behind saying that 1 over d squared is the same as 1 tree per square meter. So that's ultimately the idea there. You figure out your density. Okay. There's a bunch of calculations here. I'll let you read through it. It's not bad. I put it in my own words. I'm not going to read it, but you do the calculations and you convert some things. It's really not that tough. And read through it, figure it all out. You're going to get an area, or you're going to get a final value here of square footage of lumber in 1 acre. So just by standing in the woods and taking 4 data sets, you can get a very good estimate of how many square feet of lumber there is in 1 acre in that forest. It's pretty amazing, and it's really, really quite accurate. So I want you to go out and try it. It seems like a lot of work. It's really not. In about a half-hour time, you can be done. And they can figure out like the number of trees per acre, the average size of trees, how much lumber is available there, and then they can really figure out how old the forest is too. So that's how they do it. So your job, you're going to go out and enjoy this and enjoy nature and walk around and find a little forest and do this in 4 different spots and try it out. Use, if you don't want to do that, if you don't want to go outside, it's too cold, it's too windy, you don't feel like going outside, I do have a sample worksheet that I'll post that you can go ahead and do instead. It's boring, but it's an option. So just wanted to give you an option. All right, final thing here, crazy fact. In northern Minnesota, there were German POW camps. Most people don't know that, in northern Minnesota. And they were set up during World War II. They sent German prisoners of war here. And they sent them here to work as lumberjacks. They gave them axes and saws, and they just said, go out and log trees. In like 1944, 2 of them decided to escape in northern Minnesota and paddle a raft from Lake Winnebagochish all the way to New Orleans, about 1,200 miles along the Mississippi River. They started in November, didn't realize it was freezing cold. That was a big mistake, and they ended up turning themselves in after 3 days of hiding in the wilderness and freezing almost. They'd only traveled 20 miles. So kind of a weird story. Right by my cabin, there is actually like old remnants of a work camp from a German POW work camp. Really kind of a crazy piece of history that Minnesota hosted German prisoners of war. Kind of crazy. Anyway, that's what you got. Good luck with this, and I hope to post everything and clarify everything, but I think that'll take care of it.